we're going to look at collisions a couple different times. So this is an example of collisions. And for this first one, I want to look at a one-dimensional collision. So I'm going to start, I'm going to have this box, mass equals 5 kilograms, and it can move along at, let's go 4 meters per second. It's going to run into this box, which we can give a mass of 3 kilograms, and this one can move to the left at maybe 2 meters per second, and we are going to say these stick together. I'll do both examples, I really will. Stick together. We're going to find the final speed. So when these stick together, we have mass equals 5 kilograms, mass equals 3 kilograms. They are stuck together with some stickiness, and we're going to give these things a final speed. Now I already drew in that the final speed is to the right. It doesn't matter, honestly, whether I get that arrow direction correct or not. But in case you are the sort of person who really wants to get the arrow direction correct, I'm going to erase this for a moment and come back to it. I do want to pick a direction to be positive, and I like to the right as being positive. So, sum of momentum over here, I'm going to get an m1v1 plus an m2v2. So 5 kilograms, 4 meters per second, plus 3 kilograms, and this guy is moving to the left, so a negative 2 meters per second. 5 times 4 is 20, 3 times 2 is 6, 20 minus 6 is 14 kilogram meters per second, and that worked out to be a positive number. Now, if I really wanted to get the direction of my arrow right over here, I can say this works out to be positive, so I know this thing has to be moving to the right. My momentum after the collision is mass 1 plus mass 2, because they are stuck together, times v final. So it is 8 kilograms times v final. I am setting these things equal to each other because that's how I solve momentum problems, collision problems. So what I get is 14 kilogram meters per second equals 8 kilograms times v final. V final is going to be my 14 kilogram meter per second over 8 kilograms, which works out to be 1.75 meters per second. That's it. When they stick together, it's not too difficult of a situation. Now, it is possible, if this is 5 kilograms and 4 meters per second, and this were maybe 4 kilograms and 5 meters per second, for example, then I've got a momentum on the left side of 10 and negative 10, or 20 and negative 20 gives me 0. If that's the case, my final speed is going to be 0 because there's no net momentum to the system. And that feels awkward because there's stuff moving at first, but then afterwards there's not. It does happen though. I said this was going to be a video of collisions in one dimension, and I gave you this situation where these things stick together. Let's have them now not stick together. We can keep the speeds the same. So we'll go 5 kilograms, 4 meters per second, 3 kilograms, 2 meters per second. And here's the thing. If these are not going to stick together, then we need to be given a little bit of information about what happens afterwards. Not a ton, just enough. So we've got this block. Maybe we are looking for the final speed of this guy, but now we need to be given some information about the first block. So we will say that after the collision, this guy has almost come to a stop and is moving at, we'll go 0.4 meters per second. So it's lost 90% of its velocity. We're going to start over here. Our initial momentum is m1v1 plus m2v2. These are, of course, vectors. So I'm going to get a 5 kilograms, 4 meters per second, plus 3 kilograms, negative 2 meters per second, because I have stuck with the idea of calling something to the right positive. My final momentum, I'm going to get an m1v1 final plus m2v2 final. So 5 kilograms times 0.4 meters per second plus 3 kilograms times V2 final. I don't know the direction of V2 final necessarily, but let me get there. 5 times 4 is 20, negative 6, this is still 14 kilogram meters per second in the beginning. 5 times 0.4 is going to be 2. I've got 3 kilograms times V final. I need to get to 14. I've done 2, so this thing's going to have to be positive. 14 minus 2, that's 12, equals 3 kilograms times V final. So V final must be 3 times 4 gives me 12, 4 meters per second. It's not really any more complicated, except I now have 2 terms over here on the right side instead of having the 1. That's really about it. You can make these problems more complicated, and we'll get to that when we start talking about elastic collisions. These are not the types of problems, the more complicated version, are not the types of problems that you will have to do very often, if ever, really. So I do want to kind of de-emphasize it. It is possible, but again, not super likely.